ada mesin dia macam ni interesting lah.
Hello and good day. So I would like to present about electrocardiogram, also known as ECG, and the designation of the ECG circuit. So basically, electrocardiography is a method of graphic tracing electrocardiogram, ECG or EKG, of the electric current generated by the heart muscle during a heartbeat. The tracing is recorded with an electrocardiograph. In normal electrocardiogram, we will have PQRST wave, which P wave is the atrial depolarization. QRS complex is the ventricular depolarization and T wave is the ventricular repolarization. Note that the diagnostic mode or signal frequency range for the ECG is between 0.05 to 100 Hz. In designing ECG circuit, there will be a few things that we need to consider, and there are few components that we have to use in order to create an ECG circuit. Instrumentation amplifier is the most important component in our ECG circuit. Few reasons is that because it have very low DC offset, low drift, low noise, it should have very little noise, or if possible, no noise at all, in order to have a very smooth signal. So using components with low noise might help. Next is very high open loop gain and common mode rejection ratio, very high input impedance. So as I mentioned earlier, the diagnostic mode for this ECG is between 0.05 to 100 Hz. In this mini project, we are using an active bandpass filter, LM741, suited for use in battery operated circuits because of its high gain, low current consumption, and wide supply voltage. Active filter is basically a filter constructed using active components or components that add energy to the circuits. For example, active components used are operational amplifiers. So in a bandpass filter, we will have high pass filter and also low pass filter. So the high pass filter removes low frequency signals, while the low pass filter removes high frequency signals. Thus, the active bandpass filter is designed to allow frequency from the range of 0.05 to 100 Hz to pass through it. Finally is to use notch filter to remove power line interference of 50 Hz. Notch filter works by removing frequencies in a specified band within the overall frequency spectrum. It allows frequencies below the low cutoff point to pass along with frequency above the high cutoff point.
Hello, my name is Nurul Adilla, and I will explain about ECG signal acquisition circuit. So as we can see here, pin number 1 and pin number 8 is connected with a resistor. Then the second pin, we are connected it to the audio jack and then to the right arm. For the third pin, we are also connected to the audio jack and then to the left arm. For the fourth pin, we are connected to the negative power supply. And then for the pin number 5, we connected it to the ground. For pin number 6, we are connected to the filter and then also to the output. For the pin number 7, we are connected to the positive power supply. And pin number 8, we are connected to the resistor, which is 1 kilo ohm resistor.
In order to measure single channel ECG by using battery as power source, we are using two batteries which consists of 9-volt battery. So first, we have to connect all the crocodile clips to negative and positive batteries. Connect the positive terminal of the battery to the positive power supply pin of each component, and connect the negative terminal of the battery to the ground or common reference of the circuit.
Next part is about bandpass filter. The BPF that we used was a Salenki. Because Salenki has two filters, which is high pass and low pass filter. Let's jump to the circuit. Okay, this one is the Salenki band pass filter circuit. Okay, we start with the high pass filter. The black color, the black wire is the input, which is VA. The capacitor 1 and capacitor 2 will connect together, and then will connect using the orange wire to the pin 3, which is non-inverting input. And then in between the capacitor 1 and capacitor 2 has resistor that connect to the pin 2, which is inverting input. And then if you can see here, the resistor connect to the ground is in the same row as capacitor 2 and the orange cable. And then if, in the pin 7 here, the purple wire will connect to the low pass circuit. Pin 7 is voltage positive, and then in pin 4 is voltage negative. We also will connect to the pin 4 at low pass filter. The output in high pass filter will connect with the low pass input. So the pin 6 here is output. So the resistor will connect to the pin 6 at high pass filter, and then it will connect to another resistor, and then the other resistor will connect to the pin 3 in the low pass filter. And then in between the resistor here and here, there is the capacitor that connect to the pin 2. And then it also has a resistor capacitor that connect to the pin 3 to the ground. And then the output, the pin 6 in the low pass filter will connect to the notch circuit.
My name is RAIHANNA, and I will explain about our final ECG output signal on the oscilloscope. We used a digital oscilloscope to present our final ECG signal, and as we can see here, we have the P wave, the R wave, the S5, and the T wave. This is the result before the band pass filter, and as we can see that the signal have so many noise. This is the result after use the band pass filter, and we can see that the signal after the band pass filter is less noise than before use band pass filter. To get a nice visual of the ECG signal, the signal was scaled up to 250 milliseconds and the amplitude of 500 millivolts.